Oh, wait. Let's unpack this. Today, we're embarking on a deep dive into something really foundational for anyone navigating the world of artificial intelligence, MLOps.
Right. Kind of the engine room, isn't it?
Exactly. Think of it as the meticulous craft behind successful AI, the comprehensive set of practices and tools that turn a brilliant algorithm from just a concept into something reliable, scalable, and genuinely impactful.
Yeah. Real products.
But here's where the landscape gets really interesting, and it's shifting dramatically. AI isn't static. We're moving beyond that predictable AI, the kind that classifies, forecasts, identifies patterns.
The stuff we've gotten pretty good at managing, relatively speaking.
Right, we're moving into this incredibly dynamic, creative, and let's be honest, sometimes delightfully unpredictable world of generative AI.
Mm-hmm. A whole different beast.
So if traditional MLOps is like designing and running a super optimized assembly line for cars,
Yeah.
making them consistent, high performance,
Yeah. Predictable outputs.
then MLOps for generative AI. It's more like running a specialized bespoke workshop, crafting unique, custom-built, incredibly creative machines.
I like that analogy. It captures the uniqueness of each output.
It's about managing a process that doesn't just predict outcomes, but actively creates entirely new content, concepts, even experiences.
Yeah. Generating something novel.
So our mission in this deep dive is to really get to the core of MLOps, understand how its principles adapt for both predictive and generative AI, and crucially, shine a light on the new complexities, the tailored solutions needed for this creative frontier.
What are those new challenges they introduce? And importantly, how are organizations like Google, maybe with tools like Vertex AI, helping folks navigate this?
Exactly. We've distilled the key insights from our sources, particularly focusing on MLOps Part 1, to bring you, well, hopefully some clarity that goes beyond just the surface level stuff.
It's true. And what's fascinating here, I think, is that while the basic goals of MLOps stick around, you still need to build, deploy, manage AI reliably.
The fundamentals are still there.
Right. But this subjective, almost artistic nature of generative AI,
Yeah.
it fundamentally reimagines the whole workflow. It's not just a technical tweak. It's a profound shift in how we have to think about every single stage for these new tools. It really demands a different mindset.
Okay, so let's start by making sure we're all grounded. When we talk about MLOps, what are we really talking about?
Good place to start.
At its core, MLOps is about bringing those tried and tested best practices from DevOps.
Oh.
That whole marriage of development and operations that revolutionized software engineering.
Right. Bringing that discipline over.
Bringing that discipline to the unique world of machine learning. It's a set of, rigorous practices and robust tools designed specifically to reliably build, deploy, and then continuously manage ML systems at scale.
It's that at-scale part that's often the kicker.
Totally. Imagine you've got this brilliant prototype for a revolutionary new car. That's your ML model. Fantastic design. But that's just step one, right?
Right. Just the idea.
To actually mass produce it, you need a sophisticated factory, skilled teams, a clear, repeatable, automated process. Do you need to manufacture it consistently, test it rigorously for safety and performance, get it out to customer?
And then keep an eye on it once it's out there.
Exactly. Provide that ongoing monitoring and maintenance. MLOps is essentially that entire factory, the whole process, and that crucial feedback loop, but for machine learning models.
It really is the difference between, say, a cool science experiment in a lab.
And a scalable, dependable business capability that actually makes an impact.
Precisely. And the why behind MLOps.
Yeah.
It's just so critical, especially now that AI isn't just a side project anymore.
Huh?
It's becoming core to how businesses run.
Absolutely.
Because without that standardized, disciplined approach, trying to develop and deploy ML models, it can get incredibly messy, fast, full of inconsistencies, super time-consuming. It just doesn't scale.
Yeah, you hit a wall pretty quickly.
MLOps steps in to kind of codify and automate these often complex processes, makes them efficient, repeatable, robust. Think of maybe a Michelin star chef.
Okay.
Maybe they used to just eyeball ingredients for their signature dish, a pinch of this, a dash of that, and it was great, but maybe subtly different each time.
Right. Depends on the day. Maybe who's cooking.
Exactly.
Yeah.
MLOps gives them that meticulously standardized recipe, precise measurements, perfectly organized kitchen, maybe some automated steps. It ensures they can consistently pump out high-quality, delicious dishes every single time, no matter what.
Consistency. That's the key word.
That drive for consistent, high-quality output is Absolutely vital when you're moving from just a proof of concept to a real production AI system that, impacts customers or operations or critical decisions.
And that chef analogy, it really highlights why this isn't just some technical thing for engineers. It matters deeply to you if you're relying on AI in any way.
Mm-hmm.
It's the difference between just hoping your AI works as promised
Fingers crossed.
and actually knowing it will, predictably, reliably, at the scale your business needs. It turns that clever algorithm into a dependable, continuously improving business asset.
Well said.
Now, here's where things start getting really interesting. We often talk about AI like it's one single thing, but actually there are two fundamentally different flavors. Each has its own characteristics, and as we'll see, its own specific MLOps needs.
Absolutely. And getting this distinction right is, I think, essential. It helps explain why MLOps for generative AI isn't just a minor update, but often needs a totally different specialized approach compared to what we're used to.
Okay, let's start with the first flavor. Predictive AI. I kind of picture it as a really skilled fortune teller, but one who uses data, not crystal balls.
Huh. I like that. Data-driven fortune telling.
Its main job is to look at existing data, find patterns in it, and then make informed predictions, classifications, or decisions based on those patterns.
So it's analyzing the past to say something about the future or about current unknowns.
Exactly. Like that super shark financial analyst who pores over decades of market trends, company reports, economic indicators, and then tells you, with pretty high probability, what a specific stock is likely to do next.
Based on historical patterns.
The key thing here, predictive AI doesn't invent new information. It analyzes, recognizes patterns, and extrapolates based on what it's learned from the data it's seen.
Precisely. And we see this everywhere, right? Think about forecasting stock prices, like you said, analyzing historical data, earnings reports, maybe even news sentiment to predict up or down. It's all pattern recognition looking forward.
Okay.
Or spam detection in your email. That's predictive AI classifying an email as spam or not spam. How? By comparing its features, who sent it, keywords, maybe the formatting, against a huge database of known spam examples it's learned from.
Just classifying based on known characteristics.
Right, it's a classification task, sophisticated pattern matching. Or think about object detection, your phone, identifying a cat in a picture. The AI isn't creating the cat, it's recognizing and labeling the cat that's already in the image.
Got it. Identifying existing things.
And in healthcare, medical diagnosis systems often use predictive AI. They estimate the likelihood of a disease based on symptoms, lab results, patient history, again, analyzing existing data points to predict a probable outcome. In every case, the power comes from digging through tons of historical data, finding subtle patterns, and making an informed guess or classification. It's fundamentally about recognition, classification, extrapolation.
Okay, so that's predictive AI, the data analyst, the pattern spotter. Now, let's talk about generative AI. This is where things take a huge leap conceptually.
This is the exciting frontier right now.
This type of AI goes way beyond just predicting or classifying. It can actually create new original content that simply didn't exist before.
Creation, not just analysis.
Think of it like an incredibly talented creative artist, someone who studied thousands of paintings, sculptures, different art styles, and now they can paint entirely new pieces in those styles, or even create totally novel forms by blending influences in ways no one's seen.
Learning the essence of creativity, almost.
Yeah, it's not just recognizing the cat in the photo. It's drawing a completely new cat you've never seen before. Maybe, I don't know, floating in space in a little spaceship with cosmic whiskers. Something totally imagined.
No, the core difference is profound. It's creation, not just recognition or analysis.
Yeah.
And the examples really bring this home. You give a generative AI a simple prompt, like read a story about a time-traveling librarian.
Okay.
And it spits out a completely new narrative, maybe with surprising plot twists, characters you didn't expect, or you ask it to generate an image, a photorealistic picture of a jellyfish wearing a top hat swimming through a nebula.
Slight chuckle. Okay, I'd like to see that.
And it synthesizes that image from scratch. Blending concepts, it's learned jellyfish, top hats, nebulas into something visually coherent but totally novel. It can compose new music, generate realistic human voices from text.
Yeah.
We hear that all the time now.
Yeah, voice assistants, audiobooks.
Exactly.
Yeah.
What's truly fascinating here is that the output isn't a prediction about existing data. It's a brand new piece of content, often imaginative, that comes from the model's internal understanding of the world.
So just to really nail this down for everyone listening, one type predicts and analyzes patterns in existing data. The other creates and innovates, generating something entirely new.
That's the fundamental split.
And this difference, the shift from analysis to creation, it has huge ripple effects on how we manage these models. Every single stage of MLOps, from start to finish, it changes the game. Okay, so we've got these two distinct flavors of AI clear in our minds. Now let's walk through the typical journey of an ML model, the traditional ML workflow. Think of it like steps in a recipe.
A well-established recipe for the most part.
First up, experimentation. This is our chef back in the kitchen, trying out loads of different ingredients, cooking methods, spice blends, trying to find the absolute best recipe for a new dish.
Right. In ML terms, that's exploring different data sets, trying out various algorithms, maybe different model architectures, iterating quickly on ideas to see what shows promise. Lots of trial and error.
A real discovery phase. Then, once you've got a promising recipe, a model idea, you move to training. This is where you teach the model using lots and lots of data.
It's like our chef practicing that perfected recipe over and over.
Right.
Getting every step down a pat, committing it to muscle memory.
Exactly. The model learns from all that data, finding patterns, relationships, tuning its internal knobs, its parameters to get better and better at the task.
Lots of number crunching happens here.
Then, after all that training, comes deployment. This is the big moment you launch your model, make it available for actual use.
Like the restaurant finally opening its doors, ready to serve that dish.
Your model is live, out in the world, ready to do its job for users or systems.
Ready for customers.
Which brings us to the operational phase. Prediction, sometimes called serving or inference. This is when the live model actually does its work on new, unseen data.
Customers come in, order the dish.
And the chef your model makes it, provides the prediction, the classification, or, as we'll see, the generated content.
So that's the basic loop. Experiment, train, deploy, predict.
That's the core cycle. But as the industry matured, people realized, hang on, that's not quite enough for the real world.
Right. Things change, models degrade, you need more. Two crucial additions really evolved to make this workflow robust and enterprise-ready. First, evaluation and monitoring.
Okay, what's that about?
Well, it's not enough to just build the car and send it out. You need to constantly check. Is it still driving well? Is it safe? Is it efficient out there on real roads, which are unpredictable?
Conditions change.
Exactly. Same with the chef's dish.
Yeah.
Is it still tasting good months later? Data changes over time. We call it data drift. The characteristics of your input data shift. Maybe new types of customers start showing up.
Or the meaning of the data changes.
That too, even trickier concept drift. The relationship between inputs and the right output changes. What counts as spam evolves as spammers get smarter. So you need continuous monitoring, dashboards, alerts, regular checks, often leading to retraining the model to keep it sharp.
So it's about keeping the model performing well over time.
Yes, and the second crucial addition, log and govern. This is about keeping meticulous records of everything.
Everything.
Pretty much. Which version of the model, the exact data used to train it, the code, the parameters for training and deployment, even the monitoring results. Think of that top-tier car factory again. They keep exhaustive records for every single car. Where every part came from, which batch of steel, who worked on which part.
For traceability.
Exactly. It ensures consistency. Reproducibility, being able to recreate the exact same model or result later, which is vital for debugging or audits. And of course, compliance with rules and regulations. Connecting this back, these steps ensure your AI isn't just a one-hit wonder. It's reliable, trustworthy, and auditable throughout its life.
Okay, so that traditional MLOps workflow experiment, train, deploy, predict, plus evaluate, monitor, and log govern, it's clearly super robust for those predictive tasks. The assembly line works.
It served us well.
But now, what happens when we bring our creative artist AI into this factory? While those core steps are still necessary, generative AI throws in a whole new layer of unique challenges. It really transforms each phase, making things, well, more complex, more nuanced, more specialized.
It's not just optimizing the assembly line anymore.
Which is exactly why we're calling MLOps for generative AI the bespoke AI workshop. Regular MLOps, that's your reliable assembly line for predictive models, efficient, repeatable, consistent outputs.
Predictable results.
But MLOps for generative AI, that's about setting up and managing a specialized workshop, building unique, custom, creative AI. It takes the core MLOps ideas but adds new layers, new things to track, new ways to evaluate, tailored for these generative models.
And it immediately brings up that tricky question we touched on. How do you even evaluate if a generated story is good? Or if AI music is moving, That's so different from just checking prediction accuracy.
Totally subjective sometimes.
That subjective creative element. It changes how we have to approach almost every stage, from prepping data right through to monitoring and production. Let's break it down phase by phase, starting right at the beginning. Experimentation phase, finding the right canvas and brushes.
Okay, so right away, there's a big shift from traditional ML here. Instead of always building from scratch, training a model from zero, like building an engine piece by piece.
Which takes massive data and compute.
Generative AI often starts with these things called pre-trained foundation models. It's like walking into a really high-end art supply store. Instead of grinding your own pigments and making your own brushes from scratch, you start with a professional set of amazing pre-made paints, top-quality brushes, maybe a perfectly primed canvas. The experimentation isn't about building the basic tools. It's about choosing the right existing model, the best paints and brushes for your specific creative job, and figuring out how to use them effectively.
Exactly. And this leads to something we can call the direct prediction shortcut. With many of these big generative models, especially large language models, you can often get creative results almost instantly, just by using natural language prompts right from the get-go.
You don't always need that long training cycle first.
Not necessarily to start experimenting. It's like telling your AI artist, hey, draw me a picture of a cyberpunk city skyline at dawn, and bam, you get an image back pretty quickly. This immediate feedback totally changes how initial experimentation works. The focus shifts from heavy data training to clever prompt engineering, figuring out the right words to get the output you want.
Prototyping with language instead of just code.
You got it. Rapid iteration on the output's quality and style.
Okay, so after experimenting, we move to the customization and tuning phase, tailoring the suit. What's different here?
The big difference is the emphasis. It's usually not about full from-scratch training. It's overwhelmingly about fine-tuning or adapting an existing, powerful, general-purpose pre-trained model to fit your specific niche needs.
So less building a whole new engine, more like tweaking a powerful pre-made engine for a specific race car, or adjusting an off-road vehicle suspension for rocky terrain.
Perfect analogies. You're refining its broad capabilities for a very specific purpose. A great example. Take a huge language model, an LLM trained on like the whole internet. It knows a lot generally.
Very massive general knowledge.
Then you fine-tune it specifically to write marketing copy for your brand.
Mhm.
This fine-tuning teaches it your company's unique voice.
Yep.
Maybe it's quirky, maybe it's formal, your product details, your brand rules. So the generated copy sounds authentic, consistent, like you.
Specializing the generalist, turning broad knowledge into focused, usable output. Then there's the data aspect, curated data. Picking the perfect fabrics. How does data strategy change?
Oh, it changes significantly. With predictive AI, often the mantra was, more data is better. Quantity was key. For generative AI, while volume still matters, there's a much stronger emphasis on quality and on highly curated, domain-specific data sets.
Quality over just quantity.
Often, yes. Think about a high-fashion designer. They're not just buying fabric in bulk. They're meticulously selecting specific fabrics, the right texture, pattern, quality for a unique gown. It's the same idea here.
Careful selection.
This shift really forces organizations to rethink how they manage their data. It's not just about having a giant data lake anymore.
You need the right data in that lake.
Precisely. You need to ensure you have the right kind of high-quality data ready for fine-tuning these models effectively. And this brings up a big question for businesses. Are your current data strategies, your governance frameworks, really set up for this level of specificity and quality control? Often, it requires more human oversight, more careful labeling, maybe different storage strategies than traditional pipelines needed. It's about refining raw data into purpose-built fuel for creative AI.
Makes sense. Now, as we get deeper into this bespoke workshop, we also hit governing artifacts, tracking every design element. You mentioned new things to track.
Yes, generative AI introduces a whole new set of artifacts beyond just the model and the data set. These need careful management. We're talking about things like the tuning jobs themselves, specific adaptive layers within the model, prompt versions, and embeddings.
Okay, explain those a bit. Embeddings, adaptive layers.
Right. So tuning jobs are the records of how you customized a model. Adaptive layers are often small, specific parts of a big foundation model that get changed during fine-tuning. And embeddings, those are numerical representations of data text, images that the model uses to understand meaning. Think of them like coordinates in a meaning space.
Okay, so why track all this? Seems complex.
It is, but it's crucial. Tracking tuning jobs lets you reproduce exactly how a model was customized, vital for audits, Consistency. Managing adaptive layers helps you understand which specific parts were tweaked, giving you granular control. Controlling prompts and their versions is essential because, as we said, small wording changes can drastically alter output.
Like tracking the tailor's specific measurements, fabric swatches, thread, all the little details behind the final suit.
That's a great way to put it. And managing embeddings is key for consistency, for enabling things like semantic search over your generated content and understanding the lineage. How did this piece of content come about? Without governing these new artifacts, reproducing results, debugging, or even just understanding why a model behaves a certain way becomes incredibly difficult. It's about bringing rigor to the creative process.
Okay, now for arguably the biggest shift, the most fascinating challenge. Evaluating and monitoring, critiquing the art, and watching the gallery. We keep hitting this point. Traditional metrics like accuracy just don't cut it.
They really don't. How do you objectively measure if an AI story is good, or if generated code is elegant, or if an AI image is aesthetically pleasing? It's the art critic problem, but for AI. And beyond just good, you also need to monitor for safety, bias, factual correctness.
So what do we measure? What are the new metrics for good?
It demands a whole new evaluation framework. We need to look at things like, first, fluency. Does the output seem natural? If it's text, does it read smoothly, grammatically? Is it coherent? If it's an image, is it visually plausible without weird distortions? Does the painting flow well, or does it look messy?
Okay, fluency. Makes sense. What else?
Second, factuality. This is huge, especially when generating information. Is the content truthful? Can you verify it? Is it consistent with real-world facts, or perhaps consistent with your company's own knowledge base? If you're generating a historical summary, are the dates and events accurate, or is it making things up, hallucinating?
Right, preventing those AI hallucinations is critical for trust.
Absolutely. And third, brand reputation and safety. Does the output align with your brand's values, its tone of voice? Does marketing copy sound like your company? Critically, is it free from bias? Is it generating harmful, toxic, or inappropriate content? Does it meet ethical guidelines?
So fluency, factuality, and brand reputation safety, that's a much broader set of criteria.
Much broader and often more qualitative.
The news article example you mentioned earlier really drives this home. If AI generates news, you're checking journalistic language, fluency, verifying the facts, factuality, and ensuring it upholds the publication's credibility and avoids misinformation, brand safety.
Exactly. It takes monitoring way beyond just checking error rates. It often requires human judgment, qualitative assessment, maybe even domain experts getting involved in the MLOps loop itself. It's a complex, subjective layer that traditional models rarely had.
Definitely a different skill set needed in the MLOps team.
For sure. Closer collaboration with content folks, legal teams, ethicists sometimes.
Okay, one last piece in this transformed workflow, and it's a big one for businesses. Incorporating enterprise data, bringing your own knowledge to the artist.
Ah, yes. This is where the magic often happens for practical applications.
While those foundation models are amazing, trained on the whole internet, their knowledge is general and maybe a bit dated. The real power for a specific company comes when you can give that AI access to your own internal data, right?
Absolutely. Your proprietary documents, product specs, customer interaction histories, internal research. Giving the AI access to that makes it truly useful for your specific context.
But that must add complexity.
Oh, definitely. While it unlocks huge value, it also introduces new challenges. You need to ensure the AI is not just generally accurate, but factually accurate according to your data. You need to make sure it's relevant to your context. And you absolutely need to prevent it from hallucinating or misrepresenting your proprietary information. Plus, there are security and privacy considerations.
So it's powerful, but needs careful management. This bespoke nature of generative AI MLOps really comes through here, needing secure, validated integration with internal knowledge.
Precisely. It requires robust techniques for grounding the AI in your specific data.
So we've laid out all these unique, tricky challenges that generative AI brings to MLOps. It's pretty clear that while our existing MLOps know-how is still valuable, those core principles don't go away.
The foundation is still important.
These specific hurdles demand tailored solutions. It's not just managing the factory anymore. It's like running that dynamic creative studio, producing unique pieces of art, each needing special handling.
And what's really interesting now is seeing how platforms are stepping up to provide those tailored solutions. This is where tools like Google's Vertex AI really come into the picture. It seems designed specifically to help organizations handle this creative frontier.
Okay, so how does something like Vertex AI tackle these specific challenges we outlined? Let's start with the first big one. Increased AI infrastructure needs. The sheer compute power required the art studio's powerful computers.
Yeah, this is foundational. Generative models, especially the huge ones, are incredibly power hungry. They need massive amounts of specialized hardware GPUs, TPUs for everything from training to tuning to just running them, inference.
It's like that animation studio needing giant render farms, right?
Hmm?
Most companies can't just build that themselves.
Exactly. It's a huge barrier. Vertex AI's core solution here is offering fully managed, optimized infrastructure. Google handles the complexity, setting up the hardware, scaling it up or down automatically, maintaining it. This lets your team focus on the AI itself, not the plumbing.
Takes the infrastructure headache away.
Pretty much. And within that, they offer key components. There's the Vertex AI Model Garden. Think of it like a curated gallery of pre-built models, Google's own, popular open source ones, third-party ones. You don't have to start from absolute zero.
You pick a powerful starting point from the gallery.
Right. You can explore, find a good foundation model for your task, and often start experimenting right away, maybe just using text prompts without needing a massive training pipeline initially. Lowers the barrier significantly.
Okay, what else?
Then there's the Vertex AI Generative Studio.
Yeah.
This is like your interactive workspace. It gives you a user-friendly interface to customize those models, fine-tune them with your own data, experiment with prompts, test things out, all without managing the servers yourself. It's the user-friendly front end for the bespoke workshop.
Making it accessible beyond just deep infrastructure experts.
Exactly. And underpinning all this are the Vertex AI training and prediction services. These are the managed engines for actually doing the heavy lifting training, fine-tuning, and then deploying the models so they can serve predictions or generate content reliably at scale. They handle the auto-scaling, keeping things running smoothly.
So the whole package is designed to handle that massive infrastructure need.
Yeah, the question it answers is, how can we make it easier for teams to actually do the AI work without getting bogged down in managing complex hardware and cloud resources? It frees them up to innovate.
Okay, that covers infrastructure. What about the next challenge? Customizing and tuning generative AI models, tailoring the artwork, adapting those general models for specific needs.
Right, taking the powerful but generic foundation model and making it yours. Vertex AI offers specific tools for this. One method is supervised tuning. This works well when you have clear examples of the input and the desired output.
Like summarize this text exactly like this.
Precisely. You provide lots of examples, original text paired with your ideal summary style, maybe bullet points, maybe super concise. The model learns to replicate that specific style and format.
Got it. Good for specific structured tasks.
But what about more subjective things? Creative writing, natural conversation,
Yeah.
where there isn't one single right answer. For that, Vertex AI supports reinforcement learning with human feedback, RLHF.
Ah, RLHF. Heard a lot about that. How does it work here?
Basically, you put humans in the loop, they review the AI's outputs, rate them, give feedback on things like creativity, helpfulness, safety, tone. This human guidance helps the model learn to align with nuanced human preferences and values over time. It's key for making models more helpful, harmless, and honest, especially in conversational AI.
So humans teach it subjective goodness.
In a sense, yes, guiding its creative learning. And alongside these tuning methods, Vertex AI also provides tools for data curation, helping you prepare and use that high-quality specific domain data we talked about earlier to augment the generic knowledge of the foundation model and make it perform better on your tasks, reducing those hallucinations.
So it's really about providing the tools to refine that raw AI power into precisely controlled, tailored output for your business.
That's the goal: precision and control over creativity.
Okay, moving on. Challenge 3 was managing additional artifacts, organizing the creative process, all those new things to track. Prompts, embeddings, adaptive layers, tuning jobs. How does Vertex AI help manage that complexity?
It adapts its existing robust MLOps tools. For prompt management, while Vertex AI itself might not have a dedicated prompt store per se, it's designed to integrate smoothly with essential external tools like LangChain or weights and biases. These tools are crucial for designing, testing, versioning, and analyzing your prompts, treating them like critical code artifacts.
Because the prompt is the instruction, needs careful handling.
Absolutely. Then for embedding management, those numerical meaning vectors, Vertex AI offers its feature store. This can store, manage, and serve embeddings efficiently, which is vital for applications like semantic search or recommendation engines built on top of generative models.
Managing the model's understanding of meaning.
Right. For adaptive layer management, tracking those smaller, fine-tuned parts of a big model, the Vertex Model Registry can handle these alongside the main models, so you know exactly which components were changed for which purpose.
Granular tracking.
And finally, tuning job management, the actual process of tuning. That's orchestrated and tracked using Vertex AI pipelines. This gives you end-to-end reproducibility, lineage tracking, and auditability. You know exactly what data, code, and parameters produced a specific tuned model.
So it's about bringing that traditional MLOps rigor for tracking and reproducibility to these new, more granular generative AI artifacts.
Exactly. It shows the level of detail needed to manage this creative pipeline effectively and reliably.
Okay, now for the really tricky one. Evaluating and monitoring generative AI models. Judging the artwork, watching the audience, ensuring safety. How does Vertex AI tackle the art critic problem and safety monitoring?
This is where Vertex AI introduces some really innovative approaches, going beyond just accuracy. For evaluation, the focus shifts to those metrics we discussed: fluency, factuality, and brand reputation safety.
How do you measure those systematically?
Vertex AI evaluation services help here. They let you create evaluation datasets prompts paired with ideal human-approved responses or criteria. Then you can automatically compare the model's output against these ground truth examples using specialized metrics designed for things like summarization quality, question answering accuracy against known facts, or even toxicity levels.
Comparing against a gold standard defined by humans or specific rules.
Right. Moving beyond simple right-wrong. For ongoing monitoring and production, Vertex AI offers things like automatic safety scores. It analyzes both the input prompts and the generated outputs for potential harm, bias, or inappropriate content, providing scores and allowing filtering.
Proactive safety checks.
Yes. And also recitation checking. This helps prevent the model from just regurgitating large chunks of its training data, effectively acting like a plagiarism checker to ensure originality and avoid copyright issues. It's monitoring the quality and safety of the output itself, not just input data drift.
So it directly addresses that key question. How do you ensure the AI's creativity stays within safe, ethical, and useful boundaries?
That's the aim. Building trust by actively monitoring the novel outputs.
Okay, final challenge. Integrating generative AI models with enterprise data. Giving the artist your company's story. Making foundation models truly useful by connecting them to internal knowledge.
This is often where the real business value gets unlocked. Vertex AI provides key tools for this. One major technique involves creating embeddings from your internal data documents, databases, etc.
Turning your data into those meaning vectors again.
Exactly. These embeddings are then stored in something like Vertex AI Vector Search, or the Feature Store. When a user asks a question, the system can quickly find the most relevant chunks of your internal data based on semantic meaning, and feed that context to the generative model along with the user's query.
So the AI gets the relevant facts from your data just before it answers.
Precisely. This dramatically reduces hallucinations and makes the answers far more accurate and relevant to your specific business context. It's often called Retrieval Augmented Generation, or RG. Vertex AI also has specific grounding capabilities built into some models. These help ensure the model's response is directly based on the provided enterprise data, further improving factual accuracy.
Forcing it to stick to the provided facts.
Essentially, yes. And to make these models truly active participants in business processes, there are Vertex extensions. These let the AI connect to real-time data sources or even trigger actions in other systems.
Like checking inventory or updating a customer record.
Exactly. An AI assistant could use an extension to check real-time stock levels from your inventory database before answering a customer query, or maybe trigger an order placement in your ERP system. It moves the AI from just generating content to actually doing things based on your data and systems.
Wow. So that integration piece is really about making these powerful general models deeply knowledgeable and actionable within your specific business world.
That's the goal. Unlocking that tailored business potential. Hashtag tag tag outro.
So what a journey. We've gone from the basics of MLOps, that essential factory for reliable AI, all the way through to this intricate, bespoke workshop needed for managing generative AI, really highlighting that shift from predictable assembly lines to crafting unique digital art.
Absolutely. And I think the key takeaway is really clear. Yes, generative AI introduces significant complexity, but these tailored MLOps practices and these specialized tools, like the ones we discussed in Vertex AI, they aren't just nice to have.
They're essential.
They are absolutely essential if you want to reliably deploy, manage and govern these incredibly powerful creative AI systems in a way that actually delivers sustainable business value and, responsible innovation.
So wrapping up, what does this all mean for you listening in? As AI keeps evolving at this incredible pace, moving from prediction to genuine creation, it's worth thinking about how these tools, these practices for managing AI's creativity will shape things.
Not just technology, but whole industries.
Yeah, entire industries, maybe even how we define creativity itself.
Yeah.
What completely new forms of artistry, what innovations we haven't even imagined yet, or what new problems might MLOps for generative AI help us solve in the years ahead.
It's an exciting and slightly unknown future.
Definitely something to ponder. We hope this deep dive gave you some valuable insights. Keep exploring, keep questioning, and we hope you'll join us again next time.